Hello everyone, hope you guys are doing great. Myself Sheikh Firdaus from S5 B.pharm, roll number is 29. Today we're going to discuss about a Coulson-moffit modification. The Coulson and Moffit is the first scientists who discovered the band bond, and they given a modification over the base chain theory that there is a presence of a band bond, and due to this band bond, in a cycloalkanes, they give a ring opening reaction. This Coulson-moffit modification is also known as a band bond theory, it's also known as a banana bond theory, and it's also known as a 3-center 2-electron bond theory. Now, we'll see what is a band bond. Band bond is a special type of chemical bonding. Why it is a special type of a chemical bonding? If we see the sp3 hybridization, there is a certain amount of a character, that is S and P. The percentage of a S is 25 and the percentage of a P is 75. The S character will be increases or decreases to adapt a certain geometry. For an example, if we see the cyclopropane and cyclobutane, the geometry is like triangle, and here the geometry is like square. How many types of overlapping are there? 3. Let's see. The first type of overlapping is head-on overlapping. Second one is sideway overlapping. Third one is in between overlapping. If we see the head-on overlapping, this is p orbitals. There is a maximum overlapping between these orbitals. Maximum overlap. For an example, the sigma bond. We all know that a sigma bond is the strongest bond. And if we see the sideway overlapping, they are overlapping in the sides, like you can see there is a minimum overlapping. For an example, pi bond. We also know this, that a pi bond is the weakest bond. In between overlapping is an overlapping of in between of head-on overlapping and sideway overlapping. There is a minimum interaction of the orbitals. This is a weakest bond. We can see this type of overlapping in a band bond. The band bond is present in a cycloalkane, which give a reactions like an alkene. They behave like an alkene, also undergo in ring opening reaction. We know that the band bond is also known as a banana bond. Like it will going to be bent like this. Alkene and cycloalkane. If we compare alkanes with cycloalkanes, we know that the alkane is a highly stable as compared to cycloalkane, because the alkene having the sigma bond and it is having the maximum overlapping. So we'll see it. This is a highly stable, less stable. There is a presence of a sigma bond. There is a presence of a band bond. There is a maximum overlapping. Here is minimum overlapping. For an example, These types of overlapping are seen in alkanes, straight chain alkanes. And this type of overlapping is seen in the cycloalkanes. This is the strongest bond. We know that the sigma bond is the strongest bond and this is a weak bond. These both are a covalent bond, but due to the maximum overlapping of this alkane and here is a minimum overlapping of a cycloalkanes, that's why this is the weakest. Now we'll see the band bond in cyclopropane. What is the name of this structure? Propane. If we see the carbon number 1 and carbon number 2, it's connected by the covalent bond or a sigma bond. Now let me draw it with orbitals C1, C2, C3. This is a p orbitals and here is S. Maximum overlapping of the orbitals. You can see it is lie in a same plane. This is all about the straight chain alkane. Now we'll see it in a cyclic form. Example, cyclopropane. Carbon number 1, carbon number 2, carbon number 3. If I modify the structure, this is carbon number 2 and carbon number 3. This is p orbitals. You can see this is a band bond. Minimum overlapping. There is a minimum overlapping and it is a band bond. This bond breaks easily and gives a ring opening reaction, and it also behaves like an alkene. We've already seen this. Imagine this is a carbon number 1, carbon number 2 and carbon number 3, like in propane. If we see in a cyclopropane, this is a carbon number 1, carbon number 2 and the carbon number 3. Now the bond is banded to form a cyclic form. Now another example of a overlapping is this. This type of overlapping is seen in a straight chain. Imagine this is a maximum overlapping in a straight chain. Now in a cyclic form, the bond is no longer in a straight, it's banded like this, and it's also looked as a banana and it's also called as a band bond. The second thing that Coulson and Moffit said, according to the Bayes, we know that this is a cyclopropane. We know that this is a 60 degree according to the Bayes, but the Coulson-moffit said that this value is impossible as a carbon valence angle can never be less than a 90 degree. When there is a pure p orbitals, the angle should be more than a 90 degree to form a cyclic structure and when hybridization occurs. If we compare a cyclopropane with cyclobutane, let me draw the structure. Here, decrease in overlap is more than the cyclobutane because they have to form a geometry like triangle, and here it should form a geometry like a square. Now you guys tell me which one should be more stable. The cyclobutane. Thank you, sir, for giving us an interesting task activity, and thanks to all my dear friends. Have a nice day. Bye.